Equation of functions, May June 2017. We read 1 3. Express 9x square minus 6x plus 6 in the form ax plus b whole square plus c. A, b, c are constants. We have to express this quadratic function in completing square form. So first of all, we will make the coefficient of x square 1, 9x square minus 6x plus 6. Multiplying and dividing by 9, or simply you can say that taking 9 as a common, clearly the coefficient of x square in the bracket is 1. So minus 6 x over 9 plus 6 over 9, simplifying 9 x square minus 2x over 3 plus 2 over 3. In the bracket, there are three terms, but square term only one, x square. But in completing square, in complete square, there are two terms, square terms. So second square term, to find second square term, we divide the x term by 2x. So 2x divided by 3, this is the second x term divided by 2x. So this becomes mm, 1 over 3. Now we will take square of 1 over 3 because the square term is missing. So that becomes 1 over 9. So adding and subtracting 1 over 9 inside the bracket, x square minus 2 over 3x plus 1 over 9 minus 1 over 9. The remaining term is 2 over 3. Now the first uh, three terms are a complete square, a square of x minus 1 over 3 whole square, uh, plus 2 over 3 minus 1 over 9. We can simplify it and get 5 over 9. By LCM, 2 over 3 minus 1 over 9 becomes 5 over 9. Then multiplying by 9, 9 into x minus 1 over 3 square plus 5 over 9, and multiplied by 9, 9 and 9 are cancelled, 5. This is a completing square form, but we have to write it in the required form. The quotient of x is a. We can write 9 3 square x minus 1 over 3 whole square plus 5. So using the Nice's rule, we can write it as 3 x minus 1 over 3 whole square plus 5. Multiplying by 3 inside the bracket, this becomes 3x minus 1 whole square plus 5. This is a required form. Ax plus b whole square plus c. Here the value of a is 3. So next part of this question is the function f is defined by 9x square minus 6x plus 6. The function is same, but the domain is x is greater than or equal to p, where p is a constant. P is the smallest value of p for which f is a 1 1 function. F is a 1 1. Uh, f is a 1 1 function. So first we write the function fx in completing square form. Fx, we have already done it. We have written this in completing square form. We write here fx in completing square form, that is 9 into x minus 1 over 3 square plus 5. Now, this is a quadratic function. The graph of this will be a parabolic or parabolic, and we find from here the vertex coordinates to find the smallest value of p. The value of p actually the value of x. Now vertex coordinates, we change the sign of this, writing it in the same form as same sign. The vertex coordinates are 1 over 3, 5. Now we sketch. This is the graph of this. Vertex 1 over 3, 5. This is 1 over 3. So this is 5. This graph is not run to scale. Opens upward. This is the graph. Clearly the minimum point is 1 over 3, 5. So smallest value of p for which f is 1, 1. At this value of x, the graph is 1, function is 1, 1. So smallest value will be x over 3. This is the smallest value. The next values of x are increasing. So for this graph, this is a half graph. This is missing. So smallest value of p as for which the function is uh, f is a 1, 1 function. The smallest value of p will be this value, because the value actually the value of p is value of x. Then we can write smallest p is equal to 1 over 3. The next part of this question is, for this value of p, obtain an expression for f inverse x. And we have function fx in completing square form. To find f inverse x, we must have the quadratic function in completing square form. This is the completing square form of fx. We have to find f inverse, so we let fx is equal to y, 3x minus 1 square plus 5, making x the subject, 3x minus 1 square is equal to y minus 5, taking square root each side, 3x minus 1 is equal to plus minus y minus 5 square root, 3x is equal to 1 plus minus y minus 5 square root, uh, dividing each side by 3, this becomes 1 over 3 plus minus 1 over 3 y minus 5. uh, f inverse x will be 1 over 3 plus minus 1 over 3 x minus 5. We have replaced y by x. So now we justify which value is valid, 1 over 3 plus. or 1 over 3 minus. So it depends upon the domain of the function. Since the domain of the function is x is greater than or equal to 3, so we will take the positive value. So f inverse x finally be 1 over 3 plus 1 over 3 plus 1 over 3 x minus 5 square root. Now, next we have to state the domain of f inverse. Since the domain, since the domain range of the function and range of the inverse is equal to the domain of the function. Domain of the function is x is greater than or equal to 3, but range of f inverse, look at this. This is the range of f inverse. Range of f inverse will be equal to the domain of x. So we can write 1 over 3, 1 over 3 plus 1 over 3 x minus 5 square root domain is 1 over 3 is greater than or equal to 1 over 3. So from here 1 over 3 right or left, from right and left we cancel out. So we get 1 over 3 x minus 5 square root is greater than or equal to 0. X minus 5 greater than or equal to 0. X minus 5 greater than or equal to 0. So from here x is greater than or equal to 5. This is the domain of f inverse. This is the domain of f inverse. For next part, fourth, state the set of values of q for which the equation fx is equal to q has no solution. For no solution, there comes the concept of discriminant. Discriminant will be negative. So fx is equal to k, fx is equal to q, fx is 9x square minus 6x plus 6 is equal to q. 9x square minus 6x plus 6 minus q is equal to 0. So this is A, this is B, this is C. So no solution means B square minus 4AC. This is discriminant. Discriminant must be negative. So B square minus 4AC negative 36 minus 36 into 6 minus q is less than 0. Dividing each side by 36, we get 1 minus 6 minus q is less than 0. 1 is less than 6 minus q. Or 6 minus q is greater than 1. Minus q is greater than minus 5. Or q is multiplying each side by negative 1. The inequality sign will be changed. So q is less than 5. This is the set of values of q. The answer in inequality shows the set of values. This is the final answer.